So my name is Shaf. First name is Shaf Said. I wrote my first line of Java in 1996. I wrote this so I can relate to you, right? Otherwise, it's going to be difficult. And I've been developing code as a consultant, etc. I write for InfoQ. So there's tons of things that I could share, but most importantly, last 2 years I've been working with large language models and AI, and so many of you have so many questions, I'm sure. Like most of us, I got into this journey where I said, okay, these are interesting things. What do I do as a Java developer? How do I use it, etc., etc.? So I started to get into it, learn it, reskilled myself, if you could call it that. And now I work with a team which is called the Konveyor team. Okay, and Konveyor is an open source project, and it basically what it does is that it has tools to modernize applications. Now, the modernize term or migration term, whatever, we can interchangeably use them. If you're feeling very marketing centric right now and you had good food, I can use the term modernize. If you want to feel like migration, the real thing that we need to do, technical thing, that's the word that we use. So I use it interchangeably, but Konveyor is trying to address this problem by providing, static code analysis, assessments, etc. Just a bunch of different things. And I'm part of this team from a developer advocate sort of person. There's a big engineering team that's behind it that we work with. And about 2 years ago or 18 months ago, we started to look into how we can actually use AI to do something, because everybody was talking about it. We actually had a use case that we thought would work really well. So I'm going to show that use case to you today, or the different types of tools and use cases that we built. It would be great if you thought it was nice and you came to the community and started contributing. We are not at version 1.0 right now, so we're still whatever we're doing is in development phase. So I'm going to speak about some of those things, and I'm going to omit some of the other things in Konveyor. The part of Konveyor that I'm going to demonstrate is called Konveyor AI. So it's specifically Konveyor AI, and in short, in our team, we call it Kai. And if you've seen some of the good movies or Final Fantasy or whatever that is, right? So you know what Kai is or who Kai is, right? So Kai has many different meanings. For us, it's Konveyor AI. If you've seen this code, then you don't have to raise your hand. I'll know how old you are. So it is an enterprise Java bean, right? And that's what we used to write remote objects, RMI, IIOP. You see this somewhere in organizations lurking around. It still sits there and people use it. And we want to change that, right? Here's another example of a code, which is the string substituter. If you remember I think about two years ago, there was a CVE for text for shell, if you heard about that. And basically what it did was that you could execute code directly through JavaScript, respectfully, onto the runtime, right? So you could do that. So by just, like in this case, touching the file, it would just create that, right? So that was a CV. A lot of us were affected who were using Apache Commons. But then the big ticket item came, and this is a very interesting code. If somebody can spot what the problem is, that nobody should actually output the user input in an error. But anyways, so there's basically going to leak the password. But anyways, from a logging perspective, log for shell was also a big item, and that was quite close to Christmas, by the way. So that's I guess a lot of us had fun from the product side. We had a lot of fun fixing things. So we had a really busy time period then as well. So from a Konveyor perspective, we want to fix this, and some of the things we do is we do static code analysis. So the first thing I'm going to show you, and I'm going to build this with less slides, I hope, and more of the talking and doing the demo. So what I'll do is I'm going to switch to my demo here. Obviously, let me do that. I hope I put the right password. Yeah. Okay. So so Konveyor has this CLI which is called Kantra. And Kantra is a tool which does static code analysis. So if you're familiar with static code analysis is going to go through your entire file. It's going to try to read it, understand it, and make some context out of it, right? So that's the first step to actually even understanding what the code is doing. There are a couple of tools that are already out there. There's Open Rewrite, there's some other libraries. You can even do this in plain Java. There's in Konveyor we use the language server protocol, and we implement the LSP within this with another tool. And that tool becomes something called Kantra. And the Kantra is a CLI which does all the static code analysis. So here you'll see in my, very safe interpolator example over here, there's some code here. There's, no syntax in code. There's some different kind of things that I'm doing I shouldn't be doing, right? So for example, over here, can you see the code, by the way? Do I need to? Yep, sorry. I always forget that. I have a big screen at home and I always forget this. Sorry, so thank you for reminding. So here I have these, the code that's maybe offending, and I don't want to be able to use it. So what I would usually do is that for Kantra, I would create a rule, and the rule is in our favorite language, which is YAML. I guess everybody's favorite language, right? So that was sarcastic, by the way. So you have a rule ID. A rule ID over here is, hey, there's a replace method. I want you to go check the method call in the location. This is the pattern I want you to look for, etc., etc. And then, as an awesome coder I am, I've written a regular expression, right? So make my life even more harder. And then there are a couple of other, things like this as well. So this is how, the reason I'm showing you this is because this forms the basis of this AI demo that I want to show you later today. So you'll also see a message here which kind of gives some hints around how this thing could be generally fixed. What I'm going to do is I'm going to just run Kantra here. I call the analyze. I call it on my project. And one of the good things about Kantra is that you can also do testing on the CLI as well. So you can actually test your YAML files with writing more YAML files for fun, right? So basically, at the end, you're able to test it, etc. But the first thing you'd think about in your source code is you want to build a rule. So I just run this now, and it's gonna look at the target, which is OpenJDK 17 here, which I just put in, and then it's basically just gonna use my rules directory, right? So it's gonna analyze all of this, and it's gonna print out a report. Konveyor by default has about 2,400 plus rule sets that it kind of checks on. So it's not huge, but there are some good rule sets, right? So if I go back to my to my browser here, and I refresh this, you'll see that it comes out with the analysis. In here, it shows like a report, right? So there are a couple of things. It tells me that I'm using an Oracle JDK JPEG image. So when I want to export this or migrate this from JDK 7 plus to another version of OpenJDK, this is going to be missing. So I need to change that, right? I need to change the image format because that's not what I can do. It also goes into my safe interpolator. So in my rule set, I was able to provide some hints and guidelines, what's happening in my safe interpolator, perfect. On the safe interpolator class, I have two incidents which say that you're not supposed to use this SSTI kind of behavior with the replace method. It also gives things like, hey, here's the Apache common text documentation that you can revert to, etc., etc. So it's quite simple. It just does these basic things, dependencies, issues, and kind of gives me this overview, which is great. All of these tools that we know so far today does that, right? So that's the baseline. Everybody does it. We should be able to get static code analysis. We should be able to understand what's going on and what do we do next. So let's go ahead and maybe what we do next is convert this with some artificial intelligence or machine learning, whatever you want to call it, right? So I'm going to go here, and I have multiple Visual Studio codes here, so that's going to be fun demo. What I'm doing here is that I'm using a backend. So let's say I'm going to share this, and I probably have to change my keys after I show you this. But I'm using, for example, OpenAI today for this. I have the choice to use Azure OpenAI. I can use Bedrock. I can use DeepSeek, Google, whatever sort of large language model I want to use. I can host it on something locally, and like in our local test, we use Llama 70B, which runs on our OpenShift platform. So the Red Hat OpenShift container platform, we run on that. And then we can basically have more like a private sort of system, right? So then nothing is being going out. And a lot of people that I speak to say, hey, I want my private AI, but obviously private AI has some cost to it. But yes, it can happen, right? So that's what I'm doing. I'm using OpenAI here. What I'll do is I'm going to start my server, and once I start my server, it's going to try to make some verification checks that, hey, this will work with OpenAI. The next thing I have done here is that I have in my configuration, as you see, it's a cool store app. I'll go that in a bit. I have selected certain, rules, configurations, label selectors, and the label selectors here are telling me that, for example, if I go back into my label selectors, I can say, hey, I'm using, oh, sorry, I'm gonna make this bigger again. You can see that my target technology, so my source technology is Java EE. I'm using Java EE. And I want to target it with Quarkus because that's the framework I love, even though half of you use Spring Boot, and which is great. So Quarkus 3, and Jakarta EE, since Quarkus also supports the Jakarta EE library. So I want my targets to be in this space, right? So I've defined them, and then I can also add custom rules, but that's for another demo that I will show you just in a bit as well. So I've created this custom profile for my project. So what is my project? My project is basically an old Java X based Java EE application, which has a couple of services. It has a catalog service, which basically is an entire catalog of products, etc. There's an inventory service, which basically is simple. So it's a store. It's called a cool stuff store, but it's not the Red Hat cool stuff store. This is just an example cool stuff store. So you can't really buy the merch there. In demo mode only. And then there's shipping service, which is using an enterprise Java bean and the message driven bean here, etc. So there's a bunch of these services that are being used, right? What I'm going to do now is that I'm just going to quickly check. Yes. Oops, this should not be the case. Anyways, I'm going to run the analysis. Seems like, okay, that's fun. So this analysis is now running about 300, 400 rules and trying to go through the entire process of static code analysis inside the repository, right? No worries. It's good to have some background music. And so it's basically doing the static code analysis. And in the static code analysis, it's finding out things like, hey, message-driven beans are not something you use in Quarkus. So that needs to change. You can't use the add produces. You can't. So if I just type something like Java X, it's going to say, hey, you have 95 incidents of Java X. You need to change them, right? So it's basically done an entire static code analysis of my file, of my entire project, telling me you have about 149 incidents which are in your repository to convert from Java X or Java EE to something like Jakarta and Quarkus. I'm going to take one of the first services, which is order service MDB, which has roughly about, I think, 15 instances. So at this point, the rule set that I showed you, there are about violation about, let's say, 5 of those rule sets here, right? 4 rule sets. And now what I'm doing is that I'm going to attach the context that I got from the static code analysis and send it over to the large language model, right? And I'm going to ask the large language model to make a fix for me. This is different because usually, has anybody used Cursor, Juni, AI, chat, whatever to fix things? Yeah. So in all of those cases, you're chatting with the thing, right? Yeah. Here, there's no chat. We make it more boring. right? So we already figured out what needs to be done, and we call the large language model to start fixing this. And since this is a development build, things can go wrong, and hopefully they won't. But we'll see. So here you'll see that I've created some context. Enterprise Java Beans are not supported. This came from our static code analysis. This was the line that was offending the specific problem. So if I look at this line, it says, here's the problem. You need to fix, please. It goes on detail with each and every. Okay, lovely. Let's try again. I think my internet didn't work or something. Hang on. Perfect. Okay. Come on. You can do this. Yes. Okay. Okay. The scroll is not that fun. But anyway, so you can see that it starts to generate, the code. It starts to generate the reasoning for the fix. So the reasoning is not the reasoning that you usually see in your chatbots. This reasoning is being created through the static code analysis, sending over to the large language model, asking it to give us the reasons for each and every decision that it has taken, right? So now here you can see that it has changed. It says I'm going to add incoming annotations. Um, it's going to have this thing in it. I'm going to use Jakarta inject instead of JavaX inject. So it has all of this different thing, and it basically is doing is converting the entire order service message driven bean into a reactive messaging, which is in Quarkus. So JMS, does anybody remember when JMS first came to picture? 1992, 93, right? So that's like almost 30 years ago, right? So JMS converted to reactive async IO sort of a thing, right? So it's a complete change of how things are being used. It prints out this entire thing. Let's take a look at it. And it gives me this file, which basically has a patch where I can accept or reject the different changes that I want to do. So I can go back here, go into view mode, and here you'll see that, okay, hang on, I need to make it nicer. I hope you can see it. Here you'll see all the things on the left-hand side that are going red, all the things on the right-hand side going green. And this is a generation done by a large language model, right? So I've used the static code analysis. And let me be very clear, the large language model doesn't understand static code analysis if you worked with it, right? So the static code analysis that we've done, we are able to create the hints and everything from it in order to actually get the fix. And the way we get the fix is not just sending in over the whole file, we are doing it in multiple stages. And once that's happening, we are also processing that output as well. And I'll come to that, how that works, right? So here you can see that it has converted message driven annotation to application scope. It has converted the Java X to these two nice imports. You can see that it has at incoming order. So if you've used Quarkus, when Quarkus small y reactive messaging uses the at incoming annotations, which means that now it can process the topic orders from, let's say, a Kafka queue or whatever, if the application properties is set correct, right? So now you can actually start doing it in that way. You also see that it changes the exception, and this is all pretty much controlled, right, in the way we do it. So this file gets changed. I'm going to take another example here. So I'm not boring you. If I'm boring you, please do tell me. Then I'll try to just burn my demo somewhere. So now I have a shipping service, and if I look at the shipping service, it is an enterprise Java bean. It has a remote annotation, stateless annotation. It has some really funny logic here, which I don't know, but kind of makes sense. Less than 50 do this, less than 25 do this. I hope nobody writes code like that anymore. But anyways, so I'm just going to say, okay, these are 4 incidents. Get me a RAG solution for this. And we call it RAG solution because you do not need to fine tune the model to do this, right? It's a very simple thing. We're basically using things like few shots. Have you heard about few shots? Anybody experienced that? So few shots is like telling the large language model, this is how a fix could be made. So you're kind of giving it some examples. So we're able to give it some hints and examples, and it doesn't then understands how to do this. And again, in many cases, if you were doing this migration yourself, you might end up asking the chatbot 3 times, 4 times, even 10 times, if you're as worse as I am, the same question, and it might not give you the same result. What we're able to do with this is we're able to guide that result the way we want it out, right? So using RAG, of course. So here you'll see that again, the same view. Let me open this up. It changes the code that we needed to change, right? Specifically, and we create a patch for it. So I could accept this, and I could start going on with my migration. Any questions so far?
In your previous example, you're throwing a runtime exception, and if you look at Sonar Q, will tell you don't throw a generic exception, but it doesn't point that out. So it's like, yeah. So does it apply the Java code analysis as well, or is it just the migration part?
It will. So when you talk about best practice, obviously best practice could be, well, the code that I've shown you is not the best code in the world as well, right? So it's just a demo code, and actually it's a legacy code that some of my colleagues wrote like 15 years ago, right? So, or 10 years ago roughly. So it is legacy code. It's not written in the same way. When you change it, it purely is on the rule sets that we have that define what this is. I'm going to get to the later part of the demo where you can actually define such constructs as well, to make sure, because if you were doing this for one application versus if you are able to apply this to 1,000 applications, that's the kind of tool that we're building with Konveyor. We want to be able to learn from your migration process and apply that to the rest of the applications as well.
Like, rather than you having to specify this knowledge is already available, for example. So
Yes. Yeah.
so like you don't shouldn't have to really specify the things that are already there. How do you leverage that?
That is true. So that's pure, again, that purely goes on the rule set. So if the rule set will define a certain example, or it will be the certain model that you use, different model will give you different generation at that point. Sonar Cube does it differently.
Can you import tools like Sonar Q has some rules? Can you import rules from other tools like Sonar?
You won't be able to import rules today, but you'll be able to create your own rules, right? So there's a differentiation, and that's a very interesting point. I feel like in the industry, we all are having our own way of writing rules. So maybe there's something interesting in the future that we can all do about. But yes, importing something else might not be the thing we do right now.
Import from Sonar and import in your
I can write you a
yeah,
I can write a nice CLI for you. You can convert from Sonar to this using LLM again, right? So just yeah.
you said you're providing hints to the model. Where are you providing the example?
In the large language model, sorry, in the message. So here, for example, this is the string interpolator example. It kind of gives some. This is the few shot example. You see the impact, you see the fix. I've gone a bit more deeper here with this rule, but different rules will have different sort of hints that are attached to it. So rule crafting is not like it's not extremely simple, and it's not very hard, but it's specific to your use case, right? and and that's why I say, like, if you do this for one application, you maybe have an app. Let's assume you have a proprietary framework or whatever you want to call it, a framework that is not openly available today. If I ask the large language model to convert applications to Quarkus or to Spring or Jakarta, they're quite good at giving me good results. But what if you were using libraries that don't exist in the outside world or are behind paywalls, etc.? Then you have a problem because you can't convert them so easily. So by creating your own rules, you can find that pattern and do it. And then let's say you have like 500 applications that use a specific logging framework. You change that and you make an acceptance in this tool. And I'll show you how that works in Konveyor. Then you'll be able to apply them to the rest of the 500 with the same fix as well. So you can define your practice as well as to how it should be deployed across. Yes.
So you said under the covers it's using the OpenAI models.
Right now in this demo, but it can use any large language.
OpenAI didn't give that improvement, or are you are you restricting it to your few shots, or is it a combination of what OpenAI tells you and what you specify?
Something we can look at it right after, I think, because then I have to go into the Git repo to look at the rule, what it's stating. But I would assume that this is what didn't come out, right? And that could also be because I'm using a model maybe which is not doing that exact thing, right? So, but we can take a look. So it's true, different models will generate different things, and this is a very interesting question. Even though I'm working with a project that actually does this, I can tell you that it's not easy to live with the fact that things might be generated differently. And that's something we just need to learn. In a migration process, you are maybe on a branch and you can practice and you can kind of turn around things, etc. But the point is, can we bring value to you, right? That's what it is. So, but let's take a look later. Don't let me go without that. So so here I'm just going to jump into this slide again a bit. Um, so what the idea about this is to, okay, somebody can check out the code, they can configure targets, and targets could be Quarkus, could be Camel, could be Spring Boot, Spring Framework 7. We don't specify specific frameworks. We work on these frameworks to build rules ourselves as well. So you can configure the targets, then it will do the static code analysis. Once it does the static code analysis, we use that static code analysis as the context for the large language model. Sure, you can build this yourself too. I'm not saying you can't. You can actually sit down and start doing it. Obviously, you'll hit some roadblocks, and that's what it is. And that's what we're trying to make sure, that we have an open source community where we can work with this and make it even better. Once the contextual fix is received, you would then get a patch from it, or it will generate a patch, and effectively we want to say migration is complete, right? But it's not as simple as that. There's a couple things that happen there. Yep.
Sorry, just a question. On number 4, do you use project like you have this spec, perhaps you're gonna break the code? Are there any mechanisms where I use the code and try to see if it will work?
Yeah, you're going like 3 slides ahead of me right now. So I'm getting there. I'm getting there. I'll show you exactly how what that. Yeah. That means that I'm actually on track. Yes, exactly. So yes, great question, and obviously we've been thinking about these things too, right? So this is how it basically works. You have the RAG, we have prompts, we have instructions, we have the context. We put all of that together, and then we send it to the large language model, which updates the source code, gives us the reasoning, etc. Now all of you might be just awesome Java developers, but not everybody knows about every tool, every framework, etc. So it's important for us to give you the reasoning. It's important for us to kind of lay the map for you. This is the source, this is the target. So we're also doing that in this during this exercise as well. The tool that I showed you was basically a UI with Angular 2. So maybe we can change it, Peter. And then inventory, catalog, cart, orders, payments. It's like a cool store, right? So it's like a monolith. And monoliths are not a bad thing. If I was to convert, and this application right now with all the things, in the end, the result will still be a monolith application, right? Because our tool is not going to break it, even though we can maybe apply some more hard science to it and start doing it. But it's not going to break it up. It's going to still be the monolith. It's going to be in a new framework. It's still going to work, right? That's
lucky today, I guess. Or maybe you should teach
yeah, we don't have tests yet. We are getting there. Like I said,
Could be existing, so you could do the migration and run the test on that, right?
we are not doing tests yet. Yes. So that's a very good thing, and that's something we are now looking into, is actually doing the testing part as well, right? So because that's important. Like, assuming you converted from GMS to MDB, now it's going to be hard to test with the old code. You convert EJB to REST, that's not going to be easy either. So what do you do then, right? So you have to write the test. I mean, as humans, we probably have to do something, but the tool might still be able to do. So now we have the possibility with the question that you were asking, yes, we can compile, but we should also be able to write test case if we can do good generations as well. If we can figure out that, hey, you changed this message driven bean, and now you can also change the application properties, and you can change the POM XML because of this one change, because this was missing in my last demo that I just showed you, right? It didn't change the POM, it didn't change the app props, for example. So now, because that's the problem, like, okay, sure, this is amazing, I can change the whole thing, and I change it, and then what happens is that it's not able to compile, it's not able to run because it doesn't have the dependency. Maybe me as a developer do not know which dependency it was, right? So there's some challenges there. So we want to be able to fix those challenges, right? So anyways, this was the example I think which we missed, was basically that it changed to the rest, right? The EJB at that point. So that's why testing has basically been broken by now. In other words, so what I'm going to do is that I'm going to go in something weird here, which is settings, and so I'm using we call conveyor extension, and in conveyor extension we have something called the agent mode, and you can see it says experimental, by the way. So I'm going to select the agent mode, and I feel a little bullish. I'm going to select the super agent mode too. So we're just working as we go. I'm going to stop this, and just for the sake of it, for my own sanity, I'm going to just run this again and start. So that should connect, and then just run the analysis one more time. So now what I wanted to do, let's see if it does that actually, because this is literally hot off the press from last night. So what I want the agent to do is not just generate the fix, but understand what the fix is, go into the diagnostics, look at the dependencies, what other problems it actually broke because of this one, and start to fix each and every one of them. Now I could go throughout the whole project to do this, right? So that's the fun part, and also the dangerous part, I think, in a way, because the beautiful thing about code generators is, and I might be very people might not like what I say, but I'll just say it, that code generators are awesome at writing a lot of code. So the problem with a lot of code is, once the lot of code is written, you don't know if you want to take it to production in 5 minutes or 10 minutes or 1 week until you've actually read it and you understood what it actually did, right? So there are a couple of caveats there, but so from an agent perspective, this is what I wanted to do, and then I will have the option to accept and reject fixes, and as soon as I accept and reject fixes, it should be able to do more for it, right? So I think the analysis ran. Am I in the wrong? Yeah. Okay. Code store. There. My windows are playing with me. Okay. So now I'm going to take the message order service MDB. I'm going to say get rack solution. Is going to go for a solution, and up till now in our previous build, what we were doing was that we would take the when the tool when the large language model would come back with a fix to us, sometimes we even heard messages from LLMs, different LLMs, that hey, it's unethical to migrate a Java EE application to Quarkus. So it's like, okay, that's interesting. Never heard that, but okay, we'll take it. So so now you see that the analyzer will run as soon as I accept it, and come on. Okay. Maybe I did not refresh it. That is fun part of doing demos. Hang on a second. Hmm. So somehow it didn't go back. Let's try again. One more time. We'll see if that comes back. Otherwise, I'll just skip. So from so what I was saying, like the response from large language model could be like weird, like it might not even be code. So we have to sanitize that response. Once we sanitize that response, we want to be able to do a Maven compilation on it, and then run some sanity tests on it, right? Does it actually fix the issue that we actually send it to it? Does it match, etc.? Does the context match? There's some basic checking that's done there. There's a planning agent that basically plans all of this. So what it will do is that it will create a plan for the migration, and as soon as every next step that it will start to take, it will start to kind of take that into consideration as well. We're using Visual Studio Code heavily here, as you can see. We're using the diagnostic tooling inside Visual Studio, the tool system, whether it's Maven, whether it's file system. So we're basically staying within the same ecosystem and doing it. So it seems like that. Let me just take a look. I think I have a little failure here for some odd reason. Yeah, it's somehow not able to pick it up, but at least you get the idea from the presentation, right? That's the goal that we are into, and that also pars with how you see agents today, whether it's been Juni or Cursor or whatever. Is the way they work is once the output comes back, they're able to test it, traverse it, and go back to it. And so the next question for us in the community is to say, okay, can we generate unit tests for this as well, so that we can actually sanity test it? You converted a shipping service from EJB to REST. Now, can we actually, unit test it as well? So you have some boilerplate testing in there. Yep.
Unit test, OpenAI or ChatGPT will generate a unit test as well for you. The challenge is to use the existing unit tests and migrate them as well.
Yep. Yeah. Of course. Yeah. That is part of the structure that it's already built. Yeah.
Yeah, I was just going to say, probably saying it, you were saying, if you're writing new unit tests, then you have no way of actually proving that you're doing exactly the same thing that you did before.
True.
So you kind of want to make sure that you've got those tests in
Yes.
place beforehand. So does it allow you to sort of get tests in place before, so it can prove that it does the same thing before and after?
Yes. So there are two. Obviously, I'm thinking more from an implementation perspective here, but the short answer is yes. The longer answer is that yes, you'd be able to migrate your test cases or unit tests to the newer frameworks, libraries, and working with that. The second aspect would be yes, even if it did generate something, it would miss something, right? And so the 90, you could say, okay, it will do 80-90% of the work that I wanted it to do, but there will still be new things that you have to test or check, like the EJB mocking or whatever might be very different than what REST is, and that's a different, maybe perhaps. Can we do it? Perhaps. I'm not saying we can't, but how will we do it? I don't have the answer to it yet. But yes, from an agent perspective, when an agent solves a problem, at least it should be able to write the basic boilerplate code for the actual result, to be sanitizing it for you as well, to saying, okay, this is the things that I've tested, and this is how it looks from a testing perspective as well. But they're two different things, if you understand what I mean.
Yeah, I mean, I'm also just thinking, when you go back to the agent, I do accept or objective. That's kind of like something that it could take into account.
Yeah.
When it decides, make that decision, does it pass tests? Does it do what it did before?
Come on in the community and do some more work with us. We can figure that out. Okay. No, that's good input. Yes, thanks. That's a very good point. I have to think how that's going to work, so I don't have the full solution to it. Another thing that we've implemented in the latest build from last night again is a solution server. So what we want to achieve out of the solution server is that when you actually migrate or do a migration step, we can record it. So the next time when it needs to do the fix, it is already within the system, and it can hint to the large language model how you want to fix it. Something like a certain exception framework that you might have written yourself, and you don't want the generation to be the same, or a logging framework, etc. You want it to be different, and the large language model doesn't know about it. So you want to be able to give some hints to actually to make it do that, right? So let's go ahead, and hopefully this should work. So we're gonna stop this guy, and I have a solution called the inventory management. In this inventory management, I have an audit library, and that's just a logging library. So what I'm going to do is that I'm going to ask the large language model for a fix, and then I'm going to ask it to basically add my hints to it as well. I need to do certain things before I do that. I need my database, because the database is going to store stuff. So I'm just going to quickly check that my database is empty. I'm using Postgres, as you can see at the back end, and I'm using Adminer as the the UI. So it's a nice UI to demo at least. Then what I need to do is I need to start my what we call the solution server, and I'm going to do that. I'm using Python here for this MCP server implementation that does that. So that server will start to come up. I want to be able to go again in my settings, and I have to change what I did with the agents. Konveyor agent. I think super agent failed me today, but we'll figure that out. I'm going to enable my solution server, and that's pretty much it. So I'm going to restart the extension and restart my solution server. Let's see if that works. Yes, solution server is up, and I start it up again. And here you can see that it's telling me you have a file system audit logger that needs to be converted to a streamable audit logger, right? So it has this sort of analysis already done. It points out a particular file here that, hey, this is the file that you should be changing, and then I want certain more changes to happen and not just this one. So what I'll do is that I'm going to ask it to give me a solution from the large language model, and hopefully no disconnects. It goes in, you can see its reasoning. It looks at all of the stuff. Okay, there are import statements I need to change, Here's the kind of file that I want you to change. And it is rolling in. Come on, internet. So it's generating, and this is streaming the responses. So that's why you see it's coming like this. It's not coming one file at a time, right? So it's streaming the entire response. It's going to do that. It's a long file, but while it does that, I'm gonna take some code here, some very cryptic code about logging, and I'll show you that. Which is, so we've built like a library that is internal, that is not known to large language models as of a couple of days ago, because since it's on GitHub, it would be known as well. But so it's just a library to demonstrate that if you want to change something, what we use. So it has made some changes. You can see that it says, hey, because I'm changing the import statement, I also need to change this. But then I decide while I'm doing this that, hey, I don't want you to do audit configuration like this. I want you to change it into something like this, right? So make it an audit stream, etc., because I'm using a stream audit logger now. Do that. So I'm just going to do that. Save this thing. Go back here. Say I accept this change. So now it's going to basically take this change and put it into my solution server. So if I go into my solution server and I say select Kai hints dot text from Kai hints, so you will see that it has created a hint already in the system. Now the default static code analysis said something else, right? And if you follow me, I'm actually adding extra code during the migration process. Now it has stored that for me. So when I go into something like another another application, which might be using the same library, then I should be able to see that it should have changed. So when I will try to get a fix for these things, it will show me that it was already accepted or rejected, etc., etc. Right? So it's able to kind of detect, because when I send the so if I go here, go into my developer, where's my console? Okay, hang on. Let it finish this. So what it's doing, let me recap that. So basically, what's happening is that the scenario is that, okay, large language models can do awesome generation. Well, awesome or not, but we can do static code analysis, we can do some generation. But once the generation is done, we want to be able to change that generation, and that generation has to be saved internally with us. And next time we want to generate again, we make the change with it, right? So now when the next time the code generation will be done, it should take the latest uh, hints that we provided it. This way, we also can actually have matrix. So in a project, for example, if you are having a project where um, hundreds of your applications are using the same logger, then someone in the team rejects that specific pattern that you introduced, and someone accepts that pattern as an example as well. So you'll be able to see how many accepted it, how many rejected it, as an example as well. So that's the idea of something with a solution server. It's a model context protocol that we use. It basically is using the static code analysis, it's using the database, it's sort of putting all of that together, and then using the large language model for it. The difference, what's the difference? The difference is that the standalone server is basically just generating what's based on the static code analysis and based on the rules that we had given it. And then let's say you have an exception, like you had an example. You don't like the generation the large language model did. You want to change that generation to what you want. That's where the solution server comes in. So it's able to then record that for you and then push it out for every next time when you're generating as well. It's a good way to sharing with teams. It's a good way to have patterns and practices across all of them. So it's not just chatting, right? It's a lot more than chatting. Why are we doing Konveyor AI? We're doing Konveyor AI because we want to improve the economics of migration. That's why we're doing it. The reason we're using large language model is to introduce the way that you can actually speed up your migration process. It's not Copilot, it's not Cursor, it's not Q, it's not Super Maven, whatever tool you want to call it. It's not a chatbot, it's a guided experience. I value that over a chatbot in many ways, even though I can use chatbot to learn things, etc. But when you have a guided experience, you have a guided flow to a guided end, right? And we want to be able to have that end. And that's what this does. So it combines static code analysis with the context and with the large language model. Yeah, create way more rule sets as we go forward, and you'll be able to use them. But yes, if you're just doing a one-off project, maybe there are certain rule sets you will need to. But for Quarkus, we have use cases for Oracle JDK, Open JDK, for Spring, for Spring Framework, for Spring Boot, migrations from 5, 6, and 7. For Quarkus, all of these are sort of covered. But then there are things that will not be covered. And that's where if you're migrating, just one app might not be useful. But migrating the major bulk of it, like, that would be helpful. And if we were writing more rules for Spring, it would help everybody, right? So that's what we are focused on right now. So yes, to answer your question, you're right in some form, but also there's something you can do just by single project as well. I see some hands. Yes, I have two solutions for you. The first solution is join the community. since you're already experimenting. Second solution is that agentic flow is something that you will use. So the agents, like you mentioned, they're important because they need to validate the responses, they need to recalibrate themselves, and they need to tweak the prompts and keep on changing on the fly as this happens. But yes, we also recalibrate according to that. And the one of the things is we're not saying use one model. Conveyor is an open source project, so we're saying use any model you want, and that comes with a big lift, because not every model is going to give you. But the idea is then for us to also know as migrators which model suits best. Like, there are models that are good for .NET code generation but not good for Java code generation, right? So there's going to be difference between how they're trained or what they do. Now, Apple released a diffusion model which can write code backwards to forward, right? So I don't know if you heard, like 2 weeks ago. So there's all these different things that come, and you need to choose the right model for your specific use case. But most of the top models that you will see out there, whether it's Gemini, OpenAI, whether it's Qwen, DeepSeek, Llama, all of these, they work pretty well with this. But then if you reduce the number of parameters, in some cases, the model will start behaving so weird that you will be like, what just happened? But maybe Qwen 22B might perform better than X22 or 70B, right? I don't want to name them, right? So it's like there's these differences that you have to see, and we look at these differences and we understand them, we change according to that, etc. But since you're already experimenting, you should come and hang out with us. So I'm going to finish this. Agentic AI, we already spoke about, that does validation, etc. Also, obviously, I work for Red Hat. We have a downstream product for it, which is called Developer Lightspeed. And the whole idea of it is to be able to use AI on your local private use cases as well, right? With that, I'm just going to leave you with this. I was already finishing, but yeah. So feel free to connect.